This lesson is IB Chapter 6, Section G, Geometric Series. And it's a pretty straightforward lesson. You're basically just using a couple of formulas. And the formulas are given to you on the formula sheet, both formulas that you need. The first thing we'll talk about is the nth partial sum. So if you did the third partial sum, for instance, that would be the sum of the first three terms. So the nth partial sum is the sum of the first n terms. And then the formula that you need, one of the formulas, is the sum of a geometric series and this is for a finite one, because some geometric series diverge. In other words, they don't converge to one sum. They just keep getting bigger and bigger and bigger and bigger. So this will be a finite geometric series. So S sub n, so this is the basically the nth partial sum, would be, there's one version, u sub 1 times r to the n minus 1 all over r minus 1. And then this or, you can also do u sub 1 times 1 minus r to the n all over 1 minus r. I find myself using this second one because the 1 minus r on the bottom matches the 1 minus r on top. I guess these do kind of too. But I don't know, it just seems like I end up using this one a lot. It's the one I'm familiar with and used to using. So that's the one I'll be using on these. First example will be to find the sum of 2, that's an of, plus 6 plus 18 plus 54 plus ... to 12 terms. Because if you didn't limit it, it would just keep getting bigger and bigger and bigger, and you wouldn't ever be able to find a sum of the whole sequence. Your first job, so normally if you're going to see a problem like this, you have to first of all identify what type of sequence it is. And so I'm looking at this and I'm noticing that we're multiplying by 3. So r is 3. And then you can also identify the first term, u sub 1 is 2. And you're noticing that it's geometric. So then you would go to your formula sheet and you would choose the formula that we just had. I'll write it down again. U sub 1 times 1 minus r to the n over 1 minus r. And then you just have to plug stuff in. So this will be S sub 12, the 12th partial sum. U sub 1 is 2, 1 minus r, which is 3, to the n, which is 12, all over 1 minus r. And then we just figure it out. Because 3 to the 12th is such a large number, we're going to need a calculator. Two times 1 minus 3 raised to the 12th, enter, divided by negative 2, enter. So I'm getting 5, oh no, it's gone. This is the bad thing about this, I always forget. I'm going to have to try to memorize it. 531440. And then I was thinking about this, you don't really want to round to 3 sig figs because then it won't be right, because this is an exact sum here. So, and I noticed too in the book they left it this way, thankfully. It just seems wrong to round it. Next example. Find S sub n for 9 minus 3 plus 1 minus 1/3 plus ... So again, you need to look at this and make sure, see what kind of series what kind of series. It's a series because it's being added. So I am multiplying by, you can pretty clearly see it here, by -1/3. Or right here you could do -3 divided by 9 to get your r value, which again is -1/3. 1 divided by -3 would be -1/1/3, or I mean -1/3. So clearly the r is -1/3, and the initial term is 9. Those are the two pieces of information you need in order to use the formula. And then we just go to the formula. U sub 1, I'll write it down again, 1 minus r to the n over 1 minus r. So U sub 1 is 9, 1 minus the ratio, -1/3. Notice you have to put your ratio in parentheses, and, oh, we don't have an n. Oh, you know what it just said? Oh, so you know what we're doing here is we're just going to come up with a formula. Okay. For a minute there I'm like, well, what's n? Well, they don't tell you. So what they want here, since it's just s sub n, they just want a formula in terms of n. Okay, 1 minus that, and then all over 1 minus -1/3. And then what we'll end up doing is we can simplify. This is going to be 4/3, and then we can simplify it with a 9. So I'll just come over here. We're going to have 9 over 4/3, and then times 3/4 to top and bottom. So that's going to be 27/4. And then this you can't simplify because you don't know the n. Because if n is positive, I mean not positive, boy. If n is even, then this will be an positive, this whole part will be positive, and if n is odd, this whole thing will be negative. So it's going to vary based on the n, so you can't simplify this any further. So that is the simplified formula. When you're doing these and your r's are negative, just be really careful right here. Make sure you put them in parentheses, because that's a possible error spot. And now we're going to look at, so those others, well, the ones we didn't converge, but sometimes they converge. So if the r, absolute value of the r, is less than 1, and we have a geometric sequence, actually I'll say a series because we're adding them, then the series will converge. In other words, it'll have, it's kind of like the limit, it'll actually have a sum. Alright, and then the formula for this, oh, we could talk about this. Here, I'll talk about it. So what we can do is we can start with our other formula, u sub 1 times 1 minus r to the n all over 1 minus r. And then, in this case, the absolute value of r is less than 1, so that means that it's going to be a fraction. So that means it's going to be, right here, your r is going to be like, I'll do u sub 1. We could write this as like, I'm trying to think of how I want to prove this. Sorry, I must be a little tired today. Well, you could think of it this way. If r is a fraction, like you could do like say 1/10, and because it's less than 1, you're raising it to n, that's the same as 1 over 10 to the n. And then as n gets large, because we're summing an infinite series, so it goes, the n approaches infinity, then 1 over, this is basically r to the n, isn't it? Then 1 over r to the n would approach 0. 1 divided by a very large number will be 0. So therefore, this will approach 0 as if r is less than 1 and as n gets really large, so you're summing an infinite number of these terms, then you end up with u sub 1 times 1, which is just u sub 1 over 1 minus r. And that's the formula. So it's a very easy formula to use. That's if the absolute value of r is less than 1. So that's the second important formula in this section, and it is in the formula sheet. If the absolute value of r is greater than 1, it won't converge. So you can't use this sum here. And this is for an infinite geometric series as long as the absolute value of r is less than 1. So you can add that to that as well. Now we can practice it. Oh yeah, this example is kind of cool. Right? 0, so 0.7 repeating as a rational number. And you might already know the shortcut, but let's do it with the geometric sequence technique. So 0.7 repeating is the same as, this, right? And then what you can do is you can think about, so that's the same as 7/10 plus, and then this is 7/100 plus 7/1000 plus, and so on. On and on and on, and it keeps going forever, so it's infinite. Is this a geometric series? Well, what are you going to multiply 7/10 by to get 7/100? 1/10, right? And then the same if you multiplied 7/100 times 1/10, you'd get 7/1000. So the r is 1/10, and the initial term, u sub 1, is 7/10. And then all we have to do is, because the r is less than 1, we can put it in the sum formula for an infinite series. And then I'll write it down again, it's u sub 1 over 1 minus r. So u sub 1 is 7/10, and then 1 minus 1/10. So that becomes 7/10 over 9/10. The tens will end up canceling, and you get 7/9. And you could try this on your calculator. I guess I'll do it. Do 7 divided by 9, and you will see what you get there. 0.7777. That's it for the notes. So, pretty straightforward lesson. The homework isn't bad either.